Hello, Calc 2. We didn't have enough time to cover all of the arc length chapter, so I am gonna talk about that now. So as you recall, there's really two formulas from this section. And the first one is this one, which is that arc length is the integral of the square root of 1 plus f prime squared. Okay, and the reason for that 1 plus f prime came from the Pythagorean theorem, and then adding up a bunch of little diagonal lines. So the way we put this into practice is that, say, if f of x is x squared, f prime of x is 2x, f prime of x squared is 4x squared. So then here, this integral, like say, if you're looking at, let's do black. So if you're looking at, say, a parabola from, say, like 0 to 1, like the length of that parabola is going to be the integral from 0 to 1 of the square root of 1 plus 4x squared, when the 4x came from over there. Okay, so we did this checkpoint in class for the 4/3 x to the 3/2 power, and we didn't have time to solve it, so let's solve it now. So then we'll do u is 1 plus 4x. I'm sitting in a place where it's hard to write, so let's try that a little better handwriting. So u equals 1 plus 4x, which means that du is 4 dx. So then this is going to be integral from, we'll worry about that later, but it's u to the 1/2 du, the 1/4. The 1/4 comes from the fact that 1/4 du equals dx. Okay. Then I think I'll just plug in things. So if x is 0, plug that in here, u is 1. If x is 1, plug that in here, and then we go to 5. So then du, so then this is equal to 1/4 times u to the 3/2 power, that's 2/3 from 1 to 5. So then that's 1/4 times 2/3 would be 1/6 times and 5 to 3/2 is the same thing. That would be 5 times square root of 5 minus 1 to the 3/2 would be 1. So that would be our arc length. Okay, now here's an example from the book. So they did f of x is x squared from 1 to 3. And so they do, well, here's f prime squared. We already kind of did that above. And then so the arc length is the integral from 1 to 3, 1 plus 4x squared. Then the book hasn't told you how to do these integrals. So they say, use a computer, do this. And for you guys, I think that would be okay for your homework for this section. So for the quiz for this section, I'm only going to ask you to set up integrals. Well, maybe some integrals. I might ask you, let me re-say that. I don't want to box myself into a corner. Any integral that might end up being something you don't know how to solve is really just going to be a problem to set up the integral. Okay, so the quiz questions are going to be to set up integrals in this section. So in this case, in the homework though, that doesn't ask you to set up questions. It usually asks you for the answer. So in this section right here, say I had the integral from 1 to 3, square root of 1 plus 4x squared, I could go over to, let me just pull, where is it? Desmos over, and I'll start over here. So if you, in Desmos, if you type int, it's like, oh, you must be wanting to do an integral. So here from 1 to 3 of, and then if you want to do square root sqrt, oh, looks like you want to do square root. Yep, yes, I do, Desmos. So 1 plus 4x squared dx, it's 8.26. It's easy as pie, right? Desmos just did it numerically using a method probably not too different from one we'll eventually learn a few sections from now. But for now, for this section, feel free to use numerical methods like Desmos or Wolfram Alpha or whatever, because you won't be quizzed on doing these integrals. You'll be quizzed on setting up the integrals. Cool? All right, now before we're not done yet, because there's also surface area. So when we talk about surface area of things that are like spun around, then we're thinking about like these sort of shapes, these funnel type shapes. And so that if we add up a bunch of these funnel type shapes for whatever the line is doing, then adding up all those different funnel shapes will give us this integral. So the surface area would be 2 pi f of x squared of 1 plus f prime of x squared. Or if we're doing it around the y-axis, it'll be with y's instead of x's. So let's do an example. So this is checkpoint 2.22 from your book. So if g of y is a square root of 9 minus y squared, then I'm going to do the surface area. So here we go. So another way to write g of y would be 9 minus y squared to the 1/2. And then we need to take this, we need to take the derivative for this formula because we need to find g prime of y and then square it. So g prime of y is going to be 1/2. So remember from chain rule from Calc 1, so 1/2 9 minus y squared to the negative 1/2 power, then multiplied by the chain rule says multiplied by the derivative of the inside, negative 2y. So another way to write g prime of y equals the 1/2 and the 2, 1/2 and the 2 cancel out. So I'm left with negative y, and then divide it. So a negative exponent would be negative 1/2 power would be divided by the square root of 9 minus y squared. Okay, so then g prime of y squared is y squared over 9 minus y squared. Okay, so then my formula is 2 pi times g of y times 1 plus that. So surface area equals 2 pi integral from 0 to 2 of g of y times square root of 1 plus g prime of y squared dy. Sometimes writing the formula with some things put in is a nice intermediate step. So 2 pi integral from 0 to 2. G of y is the square root of 9 minus y squared. And then also times the square root of 1 plus y squared over 9 minus y squared. Okay, dy. Well, this is looking fun. Square root times square root. So then we've got 2 pi times 0 to 2 of the square root of 9 minus y squared times, let's find a common denominator inside that other square root. So 9 minus y squared over 9 minus y squared. Turn the 1 into a 9 minus y squared over 9 minus y squared plus y squared over 9 minus y squared. Look at that, a minus y squared and a plus y squared. So this is going to equal 2 pi times 0 to 2 of square root of 9 minus y squared times the square root of 9 divided by 9 minus y squared. You guys seeing what I'm seeing yet? I think some things are going to cancel out. 2 pi 0 to 2 of square root of 9 minus y squared. Take this one, and it becomes square root of 9, which is 3 over square root of 9 minus y squared dy. So that's equal to 2 pi times integral from 0 to 2 of that cancels with that, and it's 3 dy. So this is a rectangle that's length 2 and height 3, so that's 6. So 2 pi times 6 is 12 pi. And we're done. Okay. Not everything will be as nice as that. So just like last time, I'm okay if you use some Desmos or Wolfram Alpha on this section, because I'm mostly going to be asking you to set up the integrals. I'm not as much as interested in how you solve them. I'm interested sometimes, but I'm more interested in you setting them up correctly. Okay, that completes what we didn't have time to cover in class today.